Look at the biggest, most expensive screen in your house right now. Maybe it is a massive 4K television in the living room. Maybe it is a sleek, ultra-thin old panel that cost a month of rent. It feels like the absolute peak of modern technology. But the truth is, you are staring at a century-old optical trick. For 100 years, every major leap in entertainment technology has essentially refined the same illusion. Back in the 1920s, the first cathode ray tubes trapped light behind a thick wall of glass. Over the decades, we made that glass thinner. We made the box lighter. We packed millions of tiny glowing pixels so close together that your brain is tricked into seeing a sharp image. Yet the fundamental physics of your television have not changed since your grandparents bought their first black and white set. You are still sitting on a couch staring at a flat two-dimensional surface, letting your eyes be fooled by light trapped on a wall. It is an evolutionary dead end. If you enjoy videos like this, please hit the like button, because these take real effort to research and produce. And subscribe so you do not miss the next one. Right now in laboratories, including teams in China, engineers are operating machines that show a different path. They have not simply built a better television. They have not just made a thinner panel or a sharper pixel. They are building true free space volumetric displays. In plain language, they are creating images that look like real physical three-dimensional objects floating in the open air. This is not a parlor trick. It is not a reflection done with hidden projectors and a pane of glass like the illusions you might see at a theme park or a concert. This is actual light stopped and shaped in midair so you can walk entirely around it. You can view it from any angle without wearing a bulky virtual reality headset and without looking through a piece of glass. If you think holograms are pure science fiction, you need to understand what is happening in these labs. Because if the technology reaches practical scale, that expensive flat screen hanging on your wall could one day look as outdated as a horse-drawn carriage. For the last decade, the smartest engineers in Silicon Valley knew the flat screen was approaching its limits. Companies like Apple, Meta, and Google looked at the television and the smartphone and realized there were only so many ways left to make a piece of glass more exciting. Their solution was supposed to be the next major leap. They spent tens of billions of dollars on it. But the solution was limited from the start. They built virtual reality and augmented reality headsets. They took the flat screen, shrank it to the size of a postage stamp, and strapped it directly to your face. Devices like the Apple Vision Pro or MetaQuest are impressive pieces of engineering. They pack enormous computing power into a small space. Yet they do not solve the actual problem of the flat screen. They simply hide it closer to your eyes. Think about looking out a window at a mountain. A standard television is like looking through that window from across the room. A VR headset is like taking the same window and taping it directly onto your eyeballs. No matter how close you get, you are still looking at a flat digital image pushed into your optic nerve. You are not interacting with a physical object in the room. You are wearing the window. And there is a bigger problem. Headsets isolate you from reality. When you put a heavy piece of plastic and metal over your eyes, you leave the physical world behind. You cannot easily make eye contact with the person sitting next to you. You cannot share a physical object resting on the table. You are closed off inside a private simulation. Silicon Valley has spent a fortune trying to convince consumers that this isolated experience is the inevitable future of entertainment and work. Many buyers try the heavy headsets for a few weeks, grow tired of the weight and the isolation, and leave them in a closet. Human beings generally do not want to be cut off from their own living rooms. True three-dimensional experience does not mean putting a screen closer to your eyes. It means bringing the digital object into the physical room with you. It means creating light that exists in the open air, the way a lamp or a chair occupies space. While some companies focused on making wearable screens lighter, groups of physicists and engineers, including teams in China, asked a simpler question. What if we throw the glass away completely? To build a real free space image, you have to break a fundamental habit of engineering. For a century, television makers treated light as something you trap against a flat surface. Researchers realized that to move forward, they had to stop treating light like paint on a canvas and start treating it more like clay in the physical world. They shifted focus to free space volumetric displays. To understand how radical this is, think about how a normal screen works. Your television is made of millions of flat squares called pixels. When they change color, your eye is tricked into seeing a moving picture. A volumetric display does not rely on a flat grid of pixels. It uses a voxel is a three-dimensional volume element. It does not live on a piece of glass. It exists at a specific physical coordinate floating in empty air. The problem with building a voxel has always been the basic nature of light. If you shine a flashlight into a dark room, the beam travels in a straight line until it hits a wall, a piece of dust, or your hand. Light does not simply stop in the middle of the air and hover. It needs a surface to scatter from so your eye can see it. That is why we have always needed screens. The screen is the surface that catches the light. To create a true free space image, you have to figure out a way to give the light something to hit without a permanent screen, without a wall, and without a headset. You have to give the light a temporary physical anchor in thin air. This is exactly what several research teams have managed to do. One established method uses optical trapping. Engineers use focused invisible laser beams to trap a tiny microscopic particle, often a speck of cellulose or similar material, the way invisible tweezers hold a speck of dust in a sunbeam. The lasers push against the particle from different directions and hold it perfectly still in the middle of the air. Once the particle is trapped, a second set of red, green, and blue lasers illuminates it. The speck lights up and becomes a single glowing point hovering in space. One point is useless by itself. Here is where the clever trick happens. Think about standing outside on a summer night holding a glowing If you hold your hand still, it is just a single dot of light. If you spin your arm fast enough in a circle, your eyes see a solid ring of fire. Your brain connects the dots because the sparkler moves faster than your eyes can track. A volumetric display does the same thing at speeds that are hard to imagine. The invisible laser tweezers move that single glowing particle through the air millions of times per second, tracing the outline of a spinning car, a human face, or any other shape. Because the particle moves so quickly and human vision is relatively slow, you do not see a single dot zooming around. Your brain blends the motion together. You see a solid glowing three-dimensional shape standing in the open air. You can walk a full circle around it. If it is a rendering of an apple, you see the front from one side of the room and the back from the other side. The shape physically occupies the space. Some laboratories take a different route and use highly focused lasers to create tiny points of glowing plasma in the air for a fraction of a second. Then draw shapes with those sparks. Other teams, including researchers in China, have explored luminous particles such as quantum dot microspheres that can be trapped and illuminated. The core idea remains the same. Turn empty air into a temporary screen by creating and scanning luminous points faster than the eye can follow. There is no magic glass, no mirror trick, and no bulky headset. The physics is proven. Working laboratory machines exist. The laboratory phase is succeeding. That brings us to the real challenge. When a piece of science fiction becomes an engineering reality, the companies that built their empires on the old technology have to face an uncomfortable truth. Think about the most valuable companies on the planet. Many of their businesses rest on a single foundation, the flat screen. Apple sells expensive pieces of glass that go in your pocket, sit on your desk, or strap to your wrist. Samsung and LG make billions manufacturing the actual display panels that go inside those devices and the televisions in homes. The global tech economy includes a massive supply chain dedicated to cutting, polishing, coating, and shipping flat glass. What happens to that supply chain? If free space volumetric displays ever replace traditional screens at scale, imagine the next version of a personal device. It might not be a flat rectangle at all. It could be a small, durable cylinder you carry in a pocket. When you want to watch a video or take a call, you set it on a table and the image projects directly into the air in front of you. There is no screen to crack. There is no heavy glass panel to manufacture. Whoever masters the hardware for the next human interface will hold significant influence over the next generation of consumer electronics. Right now, many companies are still investing heavily in headsets that keep you looking at glass panels, even if the panels are strapped to your face. That approach defends existing supply chains and design habits. Meanwhile, research groups are actively exploring the post-glass possibility. They are not trying to sell a heavier screen. They are trying to make the permanent screen unnecessary. The ripple effects would be wide. It is not only the big consumer brands that would feel the change. Companies that make specialized glass, the software developers who design interfaces for flat, Two-dimensional swiping. The entire ecosystem of apps and content built around rectangular screens would all need to adapt. A shift to true three-dimensional interfaces would require every operating system and every piece of content to be redesigned from the ground up. The strategic stakes are large. But before anyone throws their television in the trash, honesty is required about where the technology actually stands. What the engineering teams have built so far are laboratory breakthroughs, not finished consumer products. You cannot go online today and order a free space volumetric display for your living room. The reasons are practical. Tracking and moving a microscopic particle millions of times a second while illuminating it with precise color requires complex control systems and significant computing power. The lasers demand careful power management. Cooling systems are often needed to keep the equipment stable. Current prototypes tend to be bulky, surrounded by cables and support hardware. They look more like industrial research machines than sleek living room devices. This is exactly how every major technological shift begins. In the 1960s, the first computers filled entire rooms. They required massive air conditioning units and cost millions of dollars. They were used only by governments and large institutions. Nobody looking at those giant noisy machines imagined they would one day fit inside a pocket. The first mobile phones were the size of a brick and extremely expensive. The first flat-screen televisions were heavy, costly, and fragile. Technology almost always starts loud, expensive, and awkward. Then, engineers go to work. Over years, the processors get faster, the lasers shrink, the power requirements drop, and the cooling becomes quieter. The wall between laboratory success and a practical consumer product has not disappeared. It has simply been moved further down the calendar. The hardest conceptual step, the basic physics of creating luminous points in free space, has already been demonstrated. The remaining work is engineering scale, cost, and reliability. When that day eventually arrives, the way we live with images will change. Imagine walking into a living room 10 years from now. You sit down, but you do not point a remote at a giant black rectangle on the wall. A small device on the table quietly activates. You want to watch a sports match? A miniature field appears in the empty air in front of you. The players glow in three-dimensional space. If you want to examine a controversial play, you simply lean and look around the defender yourself instead of waiting for a camera operator to change angles. You are observing the volume of the action happening in real time inside your house. Think about how we communicate today. A video call means staring at a flat grid of faces on a monitor. With a volumetric display, the person you are talking to could appear to sit in the chair across from you. You could read actual body language and make something closer to real eye contact. The sense of distance between cities would shrink. The impact would reach far beyond entertainment. A surgeon preparing for a complex operation could study a floating three-dimensional model of a patient's heart, walking around it to spot details a flat image might hide. An engineer could shape a new car design with gestures in the middle of a conference room. For the last 100 years, interior design has been dictated by the screen. We arrange furniture to face a wall. When the television is off, it becomes a large, dead, black rectangle dominating the room. Free space displays threaten to finally remove that black mirror from the center of domestic life. We are standing near the possible end of the pure glass era. Since the 1920s, our relationship with digital images has been trapped behind a barrier. We look through the window, but cannot reach inside. Now, researchers are working to remove the window. The digital world is beginning to spill into physical space. It is a transition similar to the jump from the telegraph to the telephone. One technology forced you to decode flat signals. The other lets you hear a real human voice. We may be crossing a similar bridge for human vision. The companies that recognize the shift early will shape the next chapter. The companies that keep assuming the flat screen is permanent may find themselves defending an older model. The flat screen in your living room has had a remarkable run. Technology rarely stands still forever. It evolves, and approaches that once sounded impossible eventually become practical. The move from light trapped behind glass to true free space volumetric images is not a simple gadget upgrade. It is a potential disruption of a trillion-dollar industry built on rectangular panels. If you enjoyed this, look at the future of displays, and want more breakdowns like it, please hit the like button, subscribe, and turn on notifications so you never miss the next one. Related videos are on the screen if you want to keep watching. Here is a question for the comments. If a consumer version of a free space volumetric display arrived in stores tomorrow at a reasonable price, would you finally replace your flat screen television? Or are you still attached to staring at the glass? Let me know what you think. I read the comments.